Hello, my name is Joseph Kofi Bomano and this is my student ID 7809275. As you can see, this is our flow chart and it starts from the startup. And from here, it checks EEPROM password. So if there are password saved in the EEPROM, it says that the password is already defined and the system move into the time 0. And if there are no passwords saved, it asks for the number of users of the system and also asks for password for each user before it comes back to save those passwords. And after that, it check if the system is in lockdown, and if yes, it check also the potentiometer and need to see if the voltage is above 4.9 or below 4.9. If it's above 4.9, it means we have the right voltage. Then it will move to check if it is on lockdown. If not, it will check for the password. And if the voltage is incorrect, meaning if the voltage is below 4.9 volts, then it will turn on the generator. And if it's greater than 4.5 volts, 4.9 volts, sorry, it will come back to the check if lockdown. And if it's not lockdown, it check for password inputs. And when you input the password, it will also check if the password is correct. If it's correct, then the door will open here. If it's wrong, the system goes into a lockdown mode and it returns back to the beginning. And this is basically our timer 0 service routine. So every 5 seconds, it will check the timer to see, it will average the time, the temperature, sorry, for every 5 seconds. If it is less than 20 degrees, the air condition will be off. If it is greater than 20 degrees, if it's more than 20 degrees, it does the mean of the last measurement and switch on the air conditions where necessary. And not spending much time, I want to also talk about a brief description of what is happening in the code. Yeah. So these are the fuses from the top. Then we included these header files and with some of the defined stuff, and we came to these are some of the characters, variables that were used, and it has been defined at this place up to here. And this is where we start This is for the function declarations. And we came to the timer 0 interrupt service routine. So with the timer 0 interrupt service routine, what we are doing here is trying to check for the voltage of the potentiometer, and if it's less or equal to 4.9 volt, which then it turns port bit RB4 on. If it's less than 4.9 volts, then it turns the port off. Then we did something similar also for the temperature. And this temperature also converted this is where the ADC bit is done, the analog to digital converter, and this also help us to convert the ADC into the BCD so that it can be displayed on the system. And from there, if the temperature, you can see if the temperature is greater or equals to 20 degrees, it display 1 as at port BRB2. If it's less than 1, if less than 20 degrees, it displays 0. And at every second the temperature is checked, and it continues doing that for 5 times, and it does the average. So all of this is 1 to 5. So this is where the average is done. It does the average, find the average, convert the whatever value to BCD from here, and display the result onto the 7-segment display. And this represents the timers. And because we are using a system-based timer, which is the same as 655535, which is the same as FFFF. When it gets to FFF, it overflows. So we needed to work out a way to work with the timer. So basically, to do that, we divided the 20 megahertz by 4, and we got 5 megahertz divided by 256, which gave us 19533 seconds. So that means that we take that value from 65535, then we'll get this value, which is B3. And that's what let me go down a bit to explain the bottom part because time is gone. And also, as you can see, this side is just the saving and checking of passwords and stuff. So whenever there's no password, the user is asked whenever there's no user installed in the EEPROM, you can see the user is asked to input the number of users who will be using the system, and this bit will save all of that. And to talk a bit about, and whenever it is saved, it is incremented by 1 and saved in EEPROM memory, and that is what is happening here. And just to talk a bit also about the circuit implementation. Obviously, I've spoken to it with the videos that is included in the project, so I wouldn't talk much about it. But what is happening here is that we have the power coming in, we have our potentiometer, we have our temperature sensor, and that is the 7-segment display. So whenever the temperature is 20 or equal to 20 or above 20 degrees, the LED light will come on. If it is less than 20 degrees, the LED light will go off. The same thing applies to the potentiometer. When I tune the potentiometer to a voltage output less than 4.9 volts, that will make the potentiometer light goes off. And what is happening here is that, yes, I think it's time.